Hello, this is Raymond Chen, and this video shows my solution to question 2 of the homework 6. For the second question, the question 2, the question given that the joint designated function of xy is equals to b when x squared plus y squared is less than or equals to 1. So the domain of the the domain of the fx joint fxy is a circle, and the fxy is equals to is something like this, and we can know that the sub-question A that need us to find B, so that the fxy is a valid joint probability density function. So we calculate the integral of the fxy dx dy, and we know that the integral of this is equals to 1 because it is a valid joint probability density function. So, and we can see that the domain of fxy is a circle, and the area of the circle which have the radius f, the r equals to 1. So the area is equals to pi r squared equals to pi. Therefore, b multiplied pi is equals to 1. So b is equals to 1 divided by pi. Now we get the fxy is equals to one divided by pi. Secondly, first we need to find the expected value of the x, and the expected value of x is equal to the integral of the x fxy dx dy. Because we know that the fxy is equals to 1 divided by pi, so and pi is not relevant to x or y, so we can separate the b, the 1 divided by pi. Next, we see that when we calculate the and we see the domain of this, and because we see that for a given x for a given x, the domain of the y is equals to negative square root of 1 minus x squared, and the upper bound is the square root of the 1 minus x squared, and this is the range of the dy. After this, we calculate the integral result is this. Next, let's calculate, because we find that the range of x, the domain of x is in -1 to 1. So the integral of this is this. And because this is the odd function, and the final result is equal to 0. Next, let's find expected value of the ex in the under the conditional of the y, the small y, the value of y. From the diagram, it is easy to say that for a given y, the expected value of x is equals to 0, because the average is 0. It is symmetric about the x equals to 0, so the expected value of x under the y condition is 0. Additionally, for every given y, the average of the expected value of x under the conditional y is always 0, because the domain is symmetric, is a circle. So we get the expected value x, variable x under the conditional of variable y is equals to 0. Thirdly, we need to calculate the expected value of the y, variable y, and it is symmetric because x, y are symmetric, so the expected value of y is equals to expected value of the x. The value is also the same, so the expected value of variable y is 0. Meanwhile, let's consider the expected value of variable y under the condition of the value x. It is when with a given x, the average, the mean value of the y is 0, because it is symmetric about the y equals to 0. Hence, the expected value of the variable y under the given value x equals to x is 0. Finally, next, for every given value of the fx, the given value of x, the average of variable y, the expected value is always equals to 0. It is easy to see from the diagram. Therefore, the expected value of y under the condition of variable x is also 0. Finally, we need to calculate the expected value of xy, which is equals to integral of the xy fxy dx dy. And we know that the joint designative function of fxy is equals to 1 divided by pi. And the domain of the y is from the negative square root of 1 minus x squared to the upper bound square root of 1 minus x squared. And also we can take this. Finally, the expected value of xy is equals to 0. The third question should ask us what to prove or disprove x, y are uncorrelated or not. Because from the previous question we know that the expected value of xy is equal to 0, and the expected value of x is equal to 0, the expected value of y is equal to 0. Therefore, the expected value of xy is equal to expected value x multiply expected value of y. Hence, xy are uncorrelated. Now the question 2 has been completed.